Okay, so remember in quadratics, we talked about two things. We had curves like this or like this. Okay? So it was either a U shape or an N shape. And we said these curves have turning points. For example, if it's a U shape, we've got a turning point here, right here, and that's the minimum point. And if it's an N shape, we've got a turning point here, and that's a maximum point. And we had different ways of figuring out or finding out these points that we discussed in quadratic. So for example, one way was that we used to complete the square. So we used to convert the function. So for example, if we have a function like this, y equals, let's say, 4x squared minus 5x plus 12. If you've got something like this, it's a function. It's a quadratic function. We would say, let's convert this to the completed square form, a into x minus h whole square plus k. And then we could say h and k is our turning point. That was one way to think about this, right? And another was, we said we could find the x coordinate of the turning point using this, x equals minus b over 2a. So that was the other method that we discussed in quadratics. Now, we're going to think about another method here that we can use to find the same thing and find the turning point of any curve, basically. So in that case, we could only use these two methods for quadratic functions, right? Now what we want to do is we want to generalize this concept and try to find the turning points for different types of curves. So it could be a cubic curve, it could be some other polynomial, it could be a square root function, it could be other types of functions as well, which we'll actually cover in paper 3 later. So it could be trigonometric functions, log functions, exponential functions. We can actually find turning points for all of them. But there's another method for that, and that's called differentiation. Differentiation ko use karke, we will be finding the turning points now. Another different names for these points that you need to remember. So for example, turning point ko ekam turning point kehte hain, of course, right? So that was one name for this. Ekam quadratics mein vertex bhi kehte the. Yahan pe in differentiation, we're going to be using another word for this as well, and that's called stationary point. Okay, and that's the same thing. So turning point पे वही चीज होती है, vertex पे वही चीज होता है, and stationary point is another name for this point, right? This point का एक और नाम है, that's called the turning point. Now, that's called the stationary point. Now, why is this called a stationary point? You think about the gradient of this curve. So, if you think about the curve, up left side पे देखो, the gradient of the curve is negative, right? So, we're going down like this. So we're going down on the left side of the turning point here in this particular curve. So your gradient is negative on the left. What about the right side? On the right side, the gradient is positive because you're going up. The curve is going up. As you move along the x-axis, your curve is going upwards. So it's a positive gradient on this side. But at this point, that's called the turning point. आपका gradient जो है वो zero होता है because that is the point where the gradient moves from the negative direction to the positive direction. And that's why it's called the turning point. Because यहाँ पे आपका graph एक तरह से direction change कर रहा है. So it was going down before, and after this point it's going up. But there's another property that's special about this point, and that is that at this point the gradient of the graph is going to be equal to zero. Because वो बिल्कुल x axis के parallel हो जाता है इस point के ऊपर. तो इस point के ऊपर हमेशा क्या आएगा? The gradient is going to be equal to zero. इस gradient zero होने की वजह से हम इसको कहते हैं stationary point, right? कि आपका gradient वहां पे zero है. And this is the property that we're now going to be using for finding the turning point on any type of curve. टर्निंग पॉइंट के ऊपर होता ये है ग्रेडियंट इज इक्वल टू जीरो. आप मिनिमम पॉइंट ले लो या मैक्सिमम पॉइंट ले लो, दोनों के केस के अंदर वी गॉट द सेम थिंग, द ग्रेडियंट इज इक्वल टू जीरो. So now if we were given a quadratic function like this, y equals 4x squared minus 5x plus 12, and we were supposed to find out the turning point of this, what we would do is we would say, let's find the derivative of this. Because gradient ko kya represent karta hai? The derivative represents the gradient. So dy by dx is equal to, how do you differentiate this? 4 is the constant, that stays as it is. 2 आके multiply होगा. 4 into 2. The power of x reduces by 1, so that's 2 minus 1. Minus 5, because if a linear function hai, you only have x, उसका gradient is just going to be the coefficient of x. That's 5. That's minus 5 here. Okay? So that's your derivative. So you simplify this, you get 8x minus 5. And now the idea is, since at the turning point, the gradient is equal to 0, that means the derivative of the curve is equal to 0. So what you do here is, you put the derivative equal to 0 for finding the turning point. Because turning point के ऊपर क्या होता है, आपका derivative equal to 0 होता है. So you can call this a turning point, you can call this the stationary point. So that's what you're going to be hearing again and again in differentiation as well. They're both the names for the same thing. So आप क्या करोगे? Derivative को equal to 0 input कर दोगे. So you get 8x minus 5 equals 0, and you get x equals 5 over 8 from this. And this is the point where the curve, this curve, is going to have its turning point. Is that okay? X equals 5 over 8 के ऊपर आपका turning point होगा. Any problems with this? Is this clear to everyone? Yes? So it's okay, you can keep sitting, you can just, wave it and you can let me know. So I can see all of you, just gesture that you understand it, and that will be great. So somebody from online, any questions? Is that okay? So this is the x coordinate of the turning point. All right. Now, how do you find the corresponding y coordinate? Any ideas? So this is the original curve.
Putting the value of x in the original curve's equation.
Exactly. So you can put it in the original curve's equation, and you'll be able to find the corresponding y coordinate. So you say y equals 4 into 5 over 8 whole square minus 5 into 5 over 8 plus 12. And you can see what that turns out to be. So you can use a calculator for this directly, and you can figure out what that is. So 4 into 25 over 32, no, sorry, 25 over 64 minus 25 over 8 plus 12. So anybody can tell me what the result is for this? Directly calculator se dekh lein. What does this result in?
167 over 16.
167 over 16. Okay, so that's the y coordinate. So that means our turning point is therefore going to be 5 over 8 and 167 over 16. This is our turning point. Okay, now I just made that example up, so that's why these coordinates are rather weird, but that's the general process. What you do is, I'm going to write down the steps now. So the steps are therefore going to be, for finding the turning point, what you do is, in fact, first you have to find the derivative. So find dy over dx, right? Because that's the gradient. Then what you do is put dy over dx equal to 0. That's the second step. And then what you do is you find the value of x from that equation. to find the x coordinate of the turning point. And finally, what you can do is you can put that point back in the original equation to find the corresponding y coordinate as well. So that's the steps that we are going to follow here. Okay, so the fourth point is you put this value of x back in the original equation to find the y coordinate, corresponding y coordinate. Okay, so these are the steps that we are going to use to find the turning point on any curve. Now, it's not just going to hold for quadratic functions, it actually holds for any type of function. Okay, so we'll see more examples as we look at a few questions, but that's going to be our standard process now. So I hope that's clear to everyone. It's not a problem. Now what we can do is, let's think about how we can figure out whether this turning point is going to be a maximum or a minimum. So ye kaise figure out karenge? That's the next thing that we need to think about now. Okay, so how do you figure out that this turning point is a maximum or a minimum? अब इसमें आपको थोड़ा सा ध्यान देना है. I already told you the final result, as in what we're actually going to be using, but we also need to, get an idea of why that is the case. So you see, there are two possibilities of the turning points. The first possibility is it's a maximum, right? That's one possibility, because maximum point here. And the other possibility is it's a minimum. It's something like this. There are only two possibilities for a turning point, right? In fact, there's actually one more. उसको हम turning point कहते हैं. एक और point पे gradient zero होता है. That's actually something like this. यहाँ पे gradient zero होता है. X cube के case में, for instance, you get something like this. But that's not part of your syllabus as such. इसको हम कहते हैं point of inflection. But we don't need to worry about this because this is not directly part of directly relevant to what we want to do here. So we only need to be concerned about maximum points and the minimum points here. Acha. Now what we have is the turning point equal to 0 already. So that's already figured out. The turning point is going to be equal to 0. So we figured that out in both cases, as the gradient is going to be equal to 0 in both cases. That is something that we have figured out. Now, how do we figure out which of these is going to be maximum, which of these is going to be minimum? Now, think about the gradient. What is happening to the gradient here? जब maximum point होता है, what is the gradient on the left side, and what is the gradient on the right side? So anybody can think, can let me know, what is the gradient on the left side of this point? Maximum के left side, gradient negative or positive? On this side.
Positive.
It's positive, right? So we are going up, right? So the gradient here is positive. Right side पे क्या होता है? The gradient is negative. So as we cross this point, as we cross this turning point, what is happening to the gradient? Is it increasing or decreasing? Positive से negative पे जा रहा है. The gradient is actually decreasing here. क्योंकि positive था पहले और बाद में negative हो रहा है, so gradient is decreasing. So that means when gradient decreases, in this case, you've got a maximum point. Does that make sense? The gradient decrease हो रहा होता है around the turning point, you have a maximum point. It's the opposite in the other case. So यहाँ पे आप देखो minimum point के case के अंदर, the gradient is negative on the left, right? And the gradient is positive on the right. So हम negative side से positive side पर जा रहे हैं. So what is happening to the gradient? Since we're going from the negative, gradient to a positive gradient, दरम्यान में जाके zero हो जाता है यहाँ पे, of course, at the turning point. What is happening to the gradient? The gradient is increasing. So we can generalize this. Gradient increase कब होता है? Turning point के अराउंड अगर gradient increase कर रहा हूँ, which of the two cases is it going to be? It's going to be a minimum point. So that's what we figured out from here. If the gradient is decreasing, it's going to be a maximum point. And if the gradient is increasing, it's going to be a minimum point. Is that clear until here? Is that clear until here? Any problems? Any questions there? Is it okay? Yes? You can just wave your hand, the people sitting there, and somebody online, if you can just respond. Okay, so I hope that's good. All right. No, you can just do that sitting there as well. That's okay. People online, I would like some responses from you at least.
Yes, sir, it's clear.
Okay, good. So, what do we understand from this? हमारे पास gradient already है. dy by dx in this case was 8x minus 5. ठीक है, उस curve के लिए it was 8x minus 5. This is the gradient function. Now this is a bit tricky to understand. ये आपका gradient function है, right? Let's call this, let's say d of x. Let's just assume it's a function of gradient, and that is 8x minus 5. So this is your gradient function. How do we understand whether a function is increasing or decreasing? Gradient बताते हैं ना कि function increase कर रहा है या decrease कर रहा है. So if you were to look at the gradient of the gradient, so think about this. So we have the gradient function, and what we want to understand is what is happening to the gradient. क्या gradient increase कर रहा है या gradient decrease कर रहा है? For that, what we do is we find the gradient of the gradient. So हम इसको एक दफा और differentiate करते हैं. हम क्या करते हैं? We find the second derivative of this. इसको हम एक दफा और differentiate करते हैं. And we represent it like this: d2y over dx squared. That's what it's represented by. So इसको हम कहते हैं second derivative. Now, let's evaluate that. d2y over dx squared, the second derivative. All you have to do is, whatever the function is, you differentiate it once more. So 8x का derivative क्या होता है? That's 8. 5 का derivative क्या होता है? Minus 5 का derivative, that is 0. So we don't need to write that. So the second derivative of the original function turns out to be 8. But what does this really represent? 8 का क्या मतलब है? It means the gradient of dy over dx of the gradient is positive. Gradient of the gradient is positive. What that mean? What does that mean? कि जो gradient है ना, वो increase कर रहा है. Gradient का rate of change जो है, वो positive है. Your gradient is increasing. That means your gradient is increasing. Gradient आपका increase कर रहा है. जब gradient increase कर रहा होता है, हमारे पास दो cases थे. Gradient increase कर रहा होता है, we say this is going to be a minimum point. So we say क्योंकि यहाँ पे second derivative positive है, because of that reason, the gradient is increasing, so we have a maximum point. So we have a minimum point, right? So that's the idea. So आप देखते हो आपका gradient increase कर रहा है या decrease कर रहा है. And how do you figure that out? By finding the gradient of that first derivative. इसको एक दफा और differentiate करते हो, and that tells you about the behavior of the gradient. If that turns out to be positive, इसका मतलब है कि आपका एक minimum point होगा because the gradient is increasing. अगर ये negative आता तो इसका मतलब होता कि आपके पास एक maximum point होता. So that's basically the background of the second derivative. Why we use the second derivative. Does that make sense? I would recommend you think about this again on your own as well. So that it's slightly confusing at first, you know, thinking about gradient of the gradient, but it makes sense when you think about it a couple of times. But what you actually have to use then is just some basic thumb rule, and that is, you find the second derivative. There are going to be two possibilities. It can either be positive or it can be negative. Now, you do not, even if you do not remember all of this background, this is what you actually need to remember at the end. If the second derivative turns out to be positive, iska matlab ye hota hai, the point that we're talking about is a minimum point. Or if second derivative negative aa jaye, the point is going to be a maximum point. So that is what is the takeaway from that discussion. So that was just the background. हम क्यों second derivative को use करते हैं? Because we are thinking about the behavior of the gradient. But this is what it leads us to. This is the result that we now need to remember. If the second derivative turns out to be positive, we're going to say it's a minimum point. And if the second derivative turns out to be negative, it's going to be a maximum point. ठीक है? Okay. Let's consider a couple of questions from me. अब इस टाइम बहुत सारे questions आपने देखे होंगे उसके अंदर in worksheet. आप बाकी questions attempt कर रहे होंगे जिन लोगों ने worksheet खोल के देखी है अभी तक. So it looks like this. Let's look at one specific question. It's question number 7 from the worksheet. Okay, so the equation of a curve is like this. It's a cubic function. सबसे पहले वो कहते हैं find dy over dx and d2y over dx square in terms of x. आपने सबसे पहले आपको वो दोनों find करने का कहा है. अब जरूरी नहीं है कि आपको हमेशा वो find करने का कहे. अगर आपसे नहीं भी कहता, आपसे सिर्फ turning point find करने का कहता है directly और आपसे उनकी nature पूछता है, this is something that you have to do. आपको dy over dx find करना होगा, आपको ये find करना होगा, आपको in any case करना होगा. फिर उसने step by step divide करके आप खुद बता दिए कि this is how we're going to go about this. ठीक है? It's not always going to be the case. यहाँ पे first part में वो क्या कहता है? Find dy over dx. Let's differentiate that. 2x minus 3 whole cube minus 6x. What do we do? 3 यहाँ पर आ गया. So let me add another line here. नीचे जाते हैं. Your y is equal to 2x minus 3 का whole cube minus 6x. How do we differentiate this? इनको अलग-अलग करना है. पहले केस के अंदर 3 goes there and gets multiplied. इस पूरे की power reduce हो जाएगी by 1. 2x minus 3 whole raised to power 3 minus 1. It becomes square. What after that?
Multiplied by g of x का derivative.
2.
I did this, which is what?
2.
It is 2, right? इसके derivative से multiply कर देंगे, आप 2 से भी multiply कर देंगे like this. And what about the derivative of minus 6x?
Sir, minus x.
That's simply minus 6. आपने dy over dx find कर लिया. ठीक है? Now you also need to find the second derivative. So that's d2y over dx square. So उसको पहले simplify कर लेते हैं. If you want, it becomes 6 into 2x minus 3 whole square minus 6. अब इसको second derivative लेना है, इसको एक दफा और differentiate कर दें. Apply the same rules. 6 वैसे ही रहा बाहर. 2 नीचे आके multiply हो गया. The power that's multiplied here. ठीक है? 2x minus 3 power reduce होगी. And then
2 आ गया sir. Multiply.
Multiply कर दें. That's the derivative of what we have inside. ठीक है? Minus 6 का derivative, what is that?
0.
That's simply 0. आप उसको ignore कर दें. लिखना चाहते हैं लिख दें. Firstly, उसके बाद simplify कर दें. So that's simply 0, right? So what do we get from here? 6 into 2 into 2, that is 24 into 2x minus 3. इसको आप ऐसे भी छोड़ दें, simplify करना चाहते हैं कर दें. That's what you get. So that's the first derivative dy by dx and the second derivative d2y over dx square. Is this fine?
सर मेरा एक
Yes.
क्वेश्चन है.
जी मोहम्मद.
सर ये जो इस तरह के नंबर्स है -6x, इनका सेकंड डेरिवेटिव हमेशा 0 ही नहीं होगा?
Yes, हमेशा 0 होगा बिल्कुल.
तो हम लोग इसको 0 कंसीडर कर सकते हैं पहले स्टेप में?
नहीं, क्योंकि dy by dx तो 0 नहीं है ना.
ओह ठीक है.
वो तो -6 ही आ रहा है, उसमें तो 0 नहीं आ रहा.
ठीक है सर.
ओके. अच्छा, अब वो कहता है find the x coordinates of the two stationary points. अच्छा देखिए, एक क्यूबिक ग्राफ है. तो क्यूबिक ग्राफ जो होता है ना, जनरली it's either like this or like this. कभी कभी वो इस तरह भी हो जाता है, x क्यूब ग्राफ ऐसा होता है और माइनस क्यूब ऐसा होता है. बट जनरली अगर आपके पास सारी टर्म्स हैं, x क्यूब वाली भी टर्म है, x स्क्वायर वाली भी टर्म है, x वाली भी टर्म है उसके अंदर, तो आपके ये फर्स्ट टू पॉसिबिलिटीज होती हैं, इनमें से कुछ होता है. और उनकी दोनों के अंदर देखें 2 टर्निंग पॉइंट्स हैं. इसी तरह आप नंबर ऑफ वो बढ़ाते जाएं, आप डिग्री बढ़ाते जाएं. क्यूबिक में 2 टर्निंग पॉइंट्स होते हैं जनरली, मैक्सिमम. तो मैक्सिमम नंबर ऑफ टर्निंग पॉइंट्स इन अ क्यूबिक ग्राफ इज 2. क्वार्टिक ग्राफ के अंदर वो 3 हो जाते हैं. आप उसको और कर दें, x पर 5 वाला कर दें, उसमें मैक्सिमम टर्निंग पॉइंट्स 4 हो जाते हैं, एंड सो ऑन. ठीक है. सो दिस इज समथिंग दैट यू शुड कीप इन माइंड. आप बस यहाँ पे 2 टर्निंग पॉइंट्स आएंगे, 2 स्टेशनरी पॉइंट्स आएंगे. ठीक है. सबसे पहले वो कहते हैं फाइंड दोस 2 टर्निंग पॉइंट्स, एंड देन यू नीड टू डिटरमिन द नेचर ऑफ ईच स्टेशनरी पॉइंट. कौन सा उसमें से मैक्सिमम है, कौन सा मिनिमम है, या दोनों मैक्सिमम है दोनों मिनिमम है. वो तो जनरली क्यूबिक में नहीं होता, बट लेट्स सी व्हाट वी कैन. यस आयान.
मैंने कुछ नहीं कहा.
सर राइट, सॉरी राइट, यू वांटेड टू से समथिंग? नो, ओके.
नहीं सर, मैंने भी कुछ नहीं कहा.
अच्छा, you were unmuted there. Okay, so let's look at part 2 now. हमने dy over dx भी फाइंड कर लिया और d2y over dx square भी फाइंड कर लिया. Now we need to find the x coordinates of the two stationary points. ठीक है. तो stationary point कैसे फाइंड करते हैं? We put dy over
Okay.
dx equal to 0. ठीक है. Why are we doing this? For finding the stationary point. अच्छा, उसने कहा आपको सिर्फ फाइंड द x कोऑर्डिनेट्स. तो आपको y कोऑर्डिनेट फाइंड करने की जरूरत नहीं है. आप सिर्फ dy by dx equal to 0 इनपुट करेंगे, you'll get 2 values of x, and then that's all that you need. उससे corresponding y coordinates, अगर आपसे उसने टर्निंग पॉइंट फाइंड करने का कहा होता, as in both, सिर्फ उसने x कोऑर्डिनेट मेंशन ना किया होता, उसने सिर्फ कहा होता find this 2 stationary points. Then you would have to find both the x coordinate and the y coordinate. ठीक है. So what do we do here? We just put this equal to 0. What do we have there? We've got 6 into 2x minus 3 whole square minus 6 equals 0. इसको आप solve कर लें. It's a quadratic equation. All of you know how to solve it.
हमेशा सिंगल डेरिवेटिव को डालते हैं. ओके.
Yes. So stationary point find करने के लिए आपने single derivative को first derivative को equal to 0 करना है. Because of the reason that we discussed, because आपकी curve अगर ऐसी है, इस पे आके आपका gradient 0 हो जाता है, तो that's why we just input that equal to 0. Okay? तो इसको आप multiple methods से solve कर सकते हैं. इसको expand करके midterm break कर लें. आप इसको square root भी ले सकते हैं if you want. Here it becomes 6 into 2x minus 3 whole square equals 6, which gives you 2x minus 3 whole square equals 1. 6 आके वहां पे divide हो गया. दोनों साइड्स पे square root ले लें. आपके पास क्या आ जाएगा? 2x minus 3 is equal to plus minus 1. Don't forget the plus minus. ठीक है. स्क्वायर रूट लेते हैं, प्लस माइनस डालते हैं वहां पे. So that's what we get. ठीक है. अब इसको 2 पार्ट्स में डिवाइड कर लें. You get 2x minus 3 equals 1 or 2x minus 3 equals minus 1. यहाँ से you get 2x equals 4 and x equals 2. And यहाँ से you get 2x equals 2 and x equals 1. So these are the two x coordinates of the two stationary points.
साथ ही दिए हैं.
Sorry Fazan, क्या कह रहे हैं आप?
मैं कह रहा हूँ इतने पास दिए हुए हैं दोनों टर्निंग पॉइंट्स.
Yeah. So आपका जो कर्व है आप सिर्फ डेस्क पे ट्राई करें बेशक आपके पास उन दोनों पॉइंट्स पे टर्निंग पॉइंट्स आएंगे ठीक है x = 1 पे और x = 2 के ऊपर. All right. What else do we need to do here? We need to find the nature of each stationary point. What do we do for that? Nature कैसे find करते हैं points की?
सर इसका इंक्रीजिंग या डिक्रीजिंग ग्रेडियंट देखना है.
या so आप सेकंड डेरिवेटिव फाइंड करते हैं. नेचर के लिए आप हमेशा क्या करते हो? सेकंड डेरिवेटिव को देखते हो. सेकंड डेरिवेटिव हमारे पास क्या था? That was d2y over dx square equal to 24 into 2x minus 3. इसको सिंप्लीफाई करके लिख लेते हैं. Calculation आसान हो. This is the same as 48x minus 72. So this is 48x minus 72. ठीक है. अब आपने फाइंड करना है कि कौन सा मैक्सिमम है और कौन सा मिनिमम है. यहाँ पे x = 2 है, यहाँ पे x = 2.
ये मिनिमम होगा 2 वाला and 1 वाला मैक्सिमम होगा.
Yes. So what you do is you just put the values here. Put the value of x. एक दफा आप x की वैल्यू 2 पुट कर दें यहाँ पे. So let's put x = 2.
ये तो दोनों पॉजिटिव नहीं है.
देखते हैं, भी फिगर आउट करते हैं. x की वैल्यू पुट करते हैं ना. अभी तो x की टर्म्स में है, तो ये पॉजिटिव भी हो सकता है, नेगेटिव भी हो सकता है. We don't know what it's going to be. Let's put values of x. x की वैल्यू हम 2 इनपुट करते हैं, तो क्या आता है? We get d2y over dx square equals 48 into 2 minus 72. What is that? 96 minus 72. That's going to be 24. x = 1 पुट करते हैं, वहां पे क्या आता है? d2y over dx square is equal to 48 into 1 minus 72. That is going to be minus 24. Now, since this is positive, it's going to be a minimum point. And since this is negative, this is going to be a maximum point. So, जब x = 2 है, so you have a minimum point, x = 2 के ऊपर, और x = 1 के ऊपर आपके पास एक maximum point. So this is our final result. These are the x coordinates of the two stationary points, and x = 2 वाला minimum होगा, x = 1 वाला maximum होगा.